what you would have learned in the videos, so it's just going to be a lot briefer. What are the rules of shading when it comes to solving inequalities? So the first thing we're going to do is we're going to take this and we're going to turn it into looking at it as if it is simply an equation. And when we set it equal to 0, our goal is to find out where on the number line will I create hashtags. The hashtags will allow us to know how I can represent the solution set that makes this mathematical statement true. Normally when we solve, we'd say things like x equals 2 or x equals 3, x equals -3, and those would be our answers. With inequalities, we generally will have a series like all x is greater than 5, and it would be impossible to write down all the values greater than 5. That's why we represent them on a number line, so we can shade in what represents the solution set or what makes this true. Underline the first two. Factoring out an x squared, I get x plus 6. Rewriting x plus 6, what quantity times x and times 6 gives us? This would be a -1. Okay, in the front and the back, I have x plus 6. Then I have an x squared minus 1 equals 0. So x plus 6 is one factor. This factors into x plus 1 and x minus 1. If you are in front of me, you're writing this down. I'm going to set each one of these factors equal to 0 and solve. That would give me one answer of -6, one answer of -1, and one answer of +1. That doesn't mean those are the solutions necessarily to this inequality. It means those are the hashtags I want to represent on the number line. So here's -6, -1, and +1. Now I have to go back and analyze this statement. Because I see a greater than, there's no line underneath. Each one of these hashtags will have an open circle. If you are in front of me, I'm going to say it once again, if you are any student that's in front of me right here, you should be taking notes on this. You're taking notes on this if you're directly in front of me. Everybody else, you're doing your own thing right now. Okay, so in this video, Mr. McFarland talked about that unless we get to special situations like duplicate or double solutions, we will always follow an alternating like yes, no, or shade, not shade, or vice versa. So how do we determine that? We can choose any number here. I always think that choosing 0 seems like the easiest. And you can use mental math or you can plug it in. Again, if you're in front of me, you're grabbing a calculator or doing the mental math. So I'm going to take 0 to the third. Anytime I plug in a value, I'm putting it in parentheses. And I'm simply going to evaluate, is this a true statement? So here is the mathematical statement. I substituted in 0 to test this region, and I got -6. So I got -6. Is -6 greater than 0? Is that a true statement? Some of you think of it as like a Pac-Man or alligator mouth. Is alligator mouth eating the larger number? No. So this is a no statement. Anything in this region would be a no. I'm not going to shade it. And then it alternates. This is yes, yes, and no. Wherever it's yes, I shade. What does that really mean? Because we don't want to just go through the procedures and not understand. It means I could choose any number in here like -5, -4, or +3, and if I plugged it in, it would make this a true statement. Let's go on to the next one. So I'm going to go ahead and factor the next one. 1 times -4 is -4. So this tells me they're going to be different signs, so different signs, and the larger number is negative. What multiplies to equal -4 and combines to give you -3 would be -4 and +1. So x minus 4 and x plus 1, and I'm going to set it equal to 0. Not to solve, but to find those hashtags. So each of these factors I set equal to 0, and I'm going to solve. I get one answer of 4 and another answer of -1. So I make my number line. There's -1 and +4. I will say a common mistake sometimes is students don't know how to number them. Remember, it's the smallest number to the left all the way to the largest number when you're going to line up your hashtag values. So I go back up to the problem, and I see a less than or equal to. This is the key. There's a line underneath. So at these places, I'm going to bubble it in. That means that -1 and +4 for this mathematical statement are true. It would make sense if you plugged it in. They are solutions to this inequality. All right, now I need to know where to shade. Knowing that it's alternate, it's either going to be shade, leave open, shade, or vice versa. I'm not going to shade, I will shade, and I'm not going to shade. So it's going to alternate. So choose any number. Again, I always think 0 is the easiest to plug in. And again, if you can, mental math is a lot quicker. 0 squared is 0, -3 times 0 is 0. 0 minus 4 is -4. Is this statement true when I substitute in 0? Is -4 less than or equal to 0? It is. -4 is less than 0. I plugged in 0. That means this whole region is true. And because I know it alternates, it's going to be no, yes, no. Okay, we're going to go on right now to example number 3 next. Example number 3. In example number 3, we're first going to review how do we rationalize a denominator. So off to the right-hand side, if I was going to solve this for x, I would recognize there's 2 solutions. I take the square root of both sides. This tells me 2 answers, so x equals plus or minus. And then that square root is going to be broken up until the numerator and the denominator. Mathematically, there's nothing wrong with that, but it's not proper. You need to rewrite this in a proper way that no longer has a radical on the bottom. So to do that, you're going to take the bottom times itself, and we need to keep the value of the fraction the same. So whatever you multiply by the bottom, you multiply by the top. So 2 times 7 is 14, 7 times 7 is 49, and now when I reduce this, I get plus or minus 14 over 7. This would be the 2x values. There's a shortcut to doing that. Give me 1 second. Okay, so there's a shortcut to doing this. Here's a shortcut. First, I need to isolate the x, so I'm dividing by 2. And then I'm back to the same scenario I had in this previous example. So I'm going to take the square root of both. I have 2 answers. How do I know that? There's the 2 answers. I break this apart, but I'm going to teach you now. Here's the shortcut to achieving the same type of answer. Take whatever the number is on the bottom and take it times the top. So my final answer is 13 times 2 is 26. And then we're going to rewrite the denominator with no radical. That's the same answer as if I would have taken the time to show all of my work. Okay, square root of 26 over the square root of 4. Okay, square root of 26 over 2. I get the exact same thing. It's the shortcut to doing that. We're going to apply that shortcut method now as we solve this inequality. So I'm going to give you a chance to write down example number 3. This is just a recap of lesson 5. So we are reviewing how do you know when to shade. I can factor out a 3x squared, and I'm left with x minus 1. Rewriting x minus 1. What quantity times x is negative 5? That's negative 5. Negative 5x and positive 5. Now both the front and back have the quantity x minus 1. In front of the first part is 3x squared. In front of the back is minus 5. And remember, we're setting it equal to 0. Not because we're solving for x per se, it's because we're trying to find those hashtags that would be on the number line. Taking each one of these quantities, I'm going to set it equal to 0 and solve. So adding 1 to the opposite side, I know one hashtag will be 1. Adding 5 to the other side, I know another hashtag is not 5, and it's not 5/3. Remember, I'm going to have 2 answers. Now, this goes back to what we just did over here. Let's apply that shortcut. I'll have plus or minus. Now, why do I have to apply the shortcut? And the reason is because there's still a radical on the denominator. This is the same thing as radical 5 over radical 3. Can't have that. Mathematically, it's not the wrong value. It's just not written proper. So I take the bottom times the top, the square root of 15 over 3. Bless you. Now, when we do this on the number line, we may not have an idea of really what that is equal to. So let's look real quick. Square root of 15, I press enter and divide by 3. So that's approximately positive and negative 1.3 if I was just going to give a little estimate here. Positive and negative 1.3, approximately, okay? Let's go ahead and make our number line. So the negative will go first. I'm not putting down negative 1.3. I want the exact. So I have negative radical 15 over 3. Then I'll have positive 1. And then I'll have positive 15 over 3. And if you're confused by that, if I just wrote these down, there's 1, 1.3, and negative 1.3. If I had to line them up from least to greatest, this would be my first, my second, and my third. Now, how do I know if I have open circles or closed circles? I go back up to the very beginning because there's a line underneath that insinuates that each one of these hash marks that we just came up with is also going to be a solution, part of the solution set to this inequality. Okay, so again, alternating because we don't have special cases, yes, no, or vice versa. I always want to go with the easiest number. I know 0 is in between here, so I'm going to plug in 0, and I think I can do it using mental math. 0 cubed is 0, 0 times 3 is 0. 0 squared is 0, 0 times anything is 0. So I have 0, 0, negative 5 times 0, 0. So I have 0, 0, 0, plus 5. So when I plug in 0, I get the statement 5 is greater than or equal to 0. Is this a true statement? When I plug in 0, is this a true statement? Is 5 greater than 0? It is. I just tested 0. 0 is in between these two hash marks, and it's true. So this is yes, and then it alternates no, no, yes. And wherever you have a yes, you shade. Wherever you shade represents part of the solution set. That means we could choose any number in the shaded region. If we plugged it back into the inequality, it would be a true statement. If you're wondering what would it look like if it wasn't a true statement, I'm making this up. This would not be a true statement. Negative 12 is not greater than 0. So I could go to the no regions if I wanted to show you. I could choose a number in the no regions, and again, it would come up with a false mathematical statement. Okay, let's go on to some special cases here. So other than the alternating, which will occur whenever we have a duplicate or a double answer, there's a special situation that will occur. Let's look at this first one and see what we can do in order to create the hash marks. So each one of those three terms, I can factor out an x squared. And I'm left with x squared in parentheses plus 1x minus 2. Again, I'm setting it equal to 0 as I try to identify what the hashtags are. Now, I'm going to take this trinomial, and let's see if it's factorable. Okay, is it factorable? So I'm going to take 1 times negative 2 and 1 on the bottom. What multiplies to equal negative 2 and combines to give you 1? Well, they're different signs. The larger is positive. So 2 and negative 1, let's see, multiplies and combines. That works. So x minus 1, x plus 2 equals 0. So don't forget about the x squared out front. So I should have 4 answers. I should have 4 answers. So remember, this is a double because there's 2 things here. So I'm going to set each one of these equal to 0, and I'm going to solve. So how do I know it's a double? Because even though there's no such thing as a plus or minus 0, both of these 2 situations equal 0. So square root, I get x equals 0. But there's 2 solutions at 0. It's a double at 0. There's 2 of them. We have to have a total of 4. There's 2 at 0. Then I'll take the next factor, set it equal to 0, and solve. I get x equals 1. And the last one I set equal to 0 and solve, and I get x equals negative 2. These just allow me to easily identify where can I find the hash marks. So I go to 0, 1, and negative 2. And now, do I have an open circle or a closed dot? It all depends on this symbol. This symbol says open circle. Now here's where this differs. We still will apply the alternating ideas, and I will make a suggestion for you. So there are 4 different regions here, 1, 2, 3, and 4. Whenever you have a double, please draw a little arrows to the left and right of the double. They will produce the exact same answer. When you have a double, they will produce the exact same answer. They will both be yes or they'll both be no. So we can't choose 0 because 0 is one of the doubles, right? We know that it's one of these hashtags. So I'm going to choose a number to the left or right. I know that whatever this produces will be the same as this. That's how doubles work. I'm going to go with negative 1. I'm going to plug it in here, and I'm going to make sure to use parentheses when I plug it in. Negative 1 to the 4th plus negative 1 to the 3rd minus 2 times negative 1 squared. So I've substituted negative 1 in, and let's see what the output is. The output is negative 2. I want to know, is this mathematical statement true when I substitute a negative 1? Is in fact negative 2 less than 0? That means, is that alligator or Pac-Man mouth eating the larger of the 2 numbers? It is. So I come up here, and that means that I checked negative 1 here. That means this is a yes, and because it's a double, this is a yes. So I shade it in. Now it still should alternate, but let's check just to make sure. So what would be an easy number to the right of 1? It would be like 2 or 3 or 4, right? Let's grab a calculator, which you guys have at home, and let's just make sure this is true. So if I plug in 2 to the 4th plus, let's go back here. If I plug in 2 to the 4th, bring back down, plus 2 to the 3rd, subtract 2 and 2 squared, I'm going to prove that anything to the right of 1 will not make sense. So I plug this in, I got an answer of 16, I rewrite it. Is 16 less than 0? No, that's not true. That's a no, and this should be a no as well, but we're going to prove it to you. So I'll try negative 3 now, any number to the left of negative 1. So negative 3 to the 4th plus negative 3 to the 3rd subtract 2 times negative 3 squared, I get 36. Is 36 less than 0? Again, that's not a true statement. These are no's. We don't shade in no's. The only solutions occur between negative 2 and 0 and between 0 and 1 to make this mathematical statement true. Okay, you ready? I want you to factor this. I'm going to give you a 30-second head start to see if you can beat me in identifying what are the hashtag marks. So we're going to finish up here. I have x squared times x plus 4. Let's make sure that all works. X plus 4. Remember, we're setting this equal to 0. Ooh, did I make a mistake here? Do you guys have a problem with this right now? Yes? I bet you I wrote down the problem wrong. Give me 1 second. I bet you that's supposed to be a 12 and I wrote it down wrong. Sure is. Let's make this into a 12. That's when messy handwriting plays a factor in your answers. Front and back both have the quantity x plus 4. Then I have x squared minus 3 equals 0. So I have x equals negative 4. That's one hashtag. Then I take x squared minus 3. I set it equal to 0. And I get x squared, when I move the 3 over, is positive 3. And so there's confusion for students to know sometimes, like, how do I know when something's a double or not a double? It means when you get the same answer twice. We're going to see that in another problem. So here I have two answers, plus or minus the square root of 3. Now there is no radical in the denominator, it's just straight across from it. So I don't need to worry about, for this particular problem, I don't need to worry about rationalizing the denominator. I'm going to go to negative 4. Negative radical 3, and positive radical 3. I look back up to this problem. There is closed dots at each one of those places. And so I know it's going to be alternating. There is no double. This is not an example of a double because it's not the same value twice. It's the same number, but it has different signs in front of each. So we'll have the alternating like yes, no, yes, no. Choose any number. I always like to choose 0. And I can do really quick here. So when I plug this in, we have 0, 0, 0. And then I end up with a statement like negative 12 is greater than or equal to 0. I know that negative 12 is not greater than 0. I tested this region. It didn't work, so this is a no, a yes, and a no. Shade in the yeses. That means I could choose any point in that shaded region, and if I plug those points back in, it would make a true statement. That is the solution set. Okay, here we go. So we are going to factor right now and solve this. What multiplies to give us 16 and combines to give us 8? That'd be 4 and 4. So I can rewrite this as x plus 4 times x plus 4. I'm setting it equal to 0. I'm setting it equal to 0, and I'm taking each of these factors or parentheses, and I'm going to solve them. Well, I don't need to write it twice. I can just solve it one time to get x equals negative 4. Now make the number line. And at negative 4, I have an open circle. At negative 4, I have an open circle. That means negative 4 is not part of the solution set. Please come up here and draw a little arrow to the left and draw a little arrow to the right. Remember, whatever happens on the left and right will be exactly the same when you have a double. This is a double. I would have negative 4 here and negative 4 here. They're exactly the same. Same number, same sign. So I can choose any number to the left and right. If it's true, they're both true. If it's false, it's all false. I'm going to choose 0 again because I think 0 is the easiest to plug in. 0, 0 plus 16. So I write down this statement. Is this statement true? Is 16 less than 0? That means all of this is false. So there is no solution for this problem. Why? Because this is a no, and this is a no. So this entire thing produces a no solution. Okay, we're going to go to our last problem. Very last problem here. Please plug in this one. X squared plus 3x plus 9 is greater than or equal to 0. So can we factor this? Go ahead and factor it, please. Can we think of anything that multiplies to give us 9 and combines to give us 3? Anybody? 1, 9. 3, 3 doesn't work. Okay, let's go quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. All over 2a. So I have negative 3 plus or minus 3 squared minus 4ac all over 2 times 1. Negative 3 plus or minus 3 squared is 9 minus 36 all over 2 times 1 is 2. I'm going to stop right here. What type of number does this produce? 9 minus 36. A negative number. And you, at this point, know that you cannot take the square root of a negative number and get a real answer. So there is going to be no hashtag here because this hashtag, this line only represents real numbers. This is a number line for only real numbers. And I'm not going to have a real number because the discriminant is negative. You'll learn later why it produces an imaginary number, but we can't take the square root of a negative number. It's not possible. So there will be no hashtag here. So I have one of two solutions if there's no hashtag. Either everything shaded or nothing shaded. So I'm going to try 0. I come back up to the original. 0 squared is 0, plus 3 times 0 is 0, so I have 0 plus 9 is 9. Is this a true statement? Is 9 greater than or equal to 0? It is true, right? If one of those two is true, then it's true. So yes, 9 is greater than 0, so I tested 0 at work. That means the entire thing works, or all real numbers work for this particular problem.